There are 6 inverse trigonometric functions. We're going to start with the basic 2 and the ones that you'll use the most. And those will be the inverses of the sine function and the cosine function. So an inverse function its definition is that it undoes. Okay, so this is a very basic definition of an inverse, and a non-formal definition of inverse is that it undoes the original function. So if we have an inverse sine function, it will undo what the sine function originally does. So here's how we like to think about this. Let's say we took an angle, I don't know, 45 degrees. Okay, and we plugged that into, let me draw this out a little bit better. We plugged it into the sine function. Well, the sine function will act on the 45-degree angle, and it will output a value, square root of 2 over 2. So that's what it spits out. Now what we want is another function, which will be the inverse. We'll put a little negative 1 up top to represent inverse. The inverse sine function that'll take this that'll take the square root of 2 over 2 as an input and kick back out 45 degrees. That's the idea. So we need a new function that takes the original output and tells us where it came from. We may want to do this with a cosine. For example, we might have pi over 3, and we'll stick it into the cosine function. And so the cosine at pi over 3, that'll spit out 1/2. But now we want to take 1/2 and we want to plug it into another function so that, and we'll call this the inverse cosine, and so that that spits back out the angle pi over 3. So whereas the original trig functions input an angle and output a real number, the inverse trig functions will input a real number and output an angle. So the inverse trig functions input a real number and the output is an angle. Now, of course, we can sit and debate, since pi over 3 is a real number, that we're outputting a real number as well. But we like to think about it as if it's occurring on the unit circle. So notation for this. Well, the function that undoes the sine function is denoted by this little negative 1 up top. Now what it does not mean is 1 over the sine. You're used to seeing that. For example, with real numbers, you're used to seeing 3 to the negative 1. Well, that's equal to 1 over 3. Now this is true because these two guys are what are called multiplicative inverses. Function inverses are different, so this does not apply here anymore. So for notation, we write this little negative 1, but it does not mean to take the reciprocal. Therefore, since 1 over sine is cosecant, the inverse sine function is not cosecant. This is a reciprocal. This is an inverse. It can also be written with this little arc in front of it. So these notations are the same. So when someone says arc sine, what they mean is inverse sine, and you'll see both of these written fairly often, and so you should get used to both notations. Now let's start out with this inverse sine function. Now here's the thing with if we're going to call something a function, we need to make sure that whatever we have for an input, we always know the output. So for example, if we say the arc sine of 1/2, we need to know exactly what number is going to get spit out here. Here's the problem. If you take a look at the unit circle, and you ask where is, so how we read this right here in words is what angle has a sine value of 1/2. That's how you read this. What angle has a sine value of 1/2? If you read it like that from here on out in the course, you'll be fine. So what angle does have a sine value of 1/2? Well, here's the thing. There's an infinite. The answer for this is there's an infinite amount of answers. For example, the angle pi over 6 has a height value of 1/2. So does 5 pi over 6. And any angle that's coterminal with pi over 6. So pi over 6 plus 2 pi, which would be 13 pi over 6. Okay, 25 pi over 6, so on and so forth in both directions. Also, 5 pi over 6 is one of them. 17 pi over 6, so on and so forth in both directions. There's an infinite amount of them. So therefore, the sine function doesn't have an inverse over its natural range and domain. Okay, so what we're going to do is we're going to restrict the output values here, the range for this. So what we're going to say is that sine, the inverse sine, or the arc sine of x, the outputs, the numbers that we can get out, the outputs will only be on the range from negative pi over 2 to positive pi over 2. Or in other words, we will restrict ourselves to angles that only occur over here. So in quadrants 1 and 4. Now be careful. When I say quadrant 4, we need to make sure that we're using the negative, not the positive. So for example, if I wanted this angle right here, I would not go this way. I would have to come back in from this side, not around this way. It has to fall on this interval. If your answer doesn't fall on that interval, it is wrong. So let me give you an example. Let's say we asked, what is the arc sine of, now remember our input is a real number, so let's say what is the arc sine of negative square root of 3 over 2. So how we read this is we want to find the angle between negative pi over 2 and pi over 2 such that the sine of that angle is equal to negative square root of 3 over 2. So now we only have these two quadrants to work in. Okay. So negative square root of 3 over 2, well, that's going to be down here like this. Okay. So we've got a 30-degree angle here, so that's going to be, now we can go ahead and just count around, but probably the best way to do this is say, because it's going to be a negative value, so we're going to have, let's see if I do this in my head right, it should be negative pi over 3. Okay. So we need an angle on this interval. Now negative pi over 3 clearly falls on this interval. Remember, that interval is from negative pi over 2 to pi over 2. So it only covers these angles right here. Now what I can't say, so let's be very clear on this. Negative pi over 3 plus 2 pi is negative pi over 3 plus 6 pi over 3, which is 5 pi over 3. So at 5 pi over 3, the sine value, if I grab my calculator here, let's see if we can get this guy to work. Sometimes it doesn't like to work on the recording here, but let's check it out. Okay. So let's make sure we're working in radians, which we are. So if we take the sine at 5 pi over 3, okay, that's the same as negative square root of 3 over 2. However, 5 pi over 3 does not fall on that interval. What does fall on that interval is negative pi over 3. And so again, if we grab our calculator and we take the sine of negative pi over 3, we get the same number. Now your calculator will generate these values for you, but I wouldn't trust the calculator to give you exact values. For example, if we hit the second key right here, and then we hit our sine, it'll say arc sine. Now if I plug in, we wanted the arc sine of negative square root of 3 over 2. So negative square root of 3 over 2. It gives us out this value. Now that value doesn't look familiar, but if I take negative pi and divide it by 3, it's the same thing. So the calculator will only output values on this interval. Okay, and that's how we find them. So all arc sine values, or all inverse sine values, have to be between negative pi over 2 and pi over 2. We input a real number, we output the angle. So the answers we get out are angles. Cosine has a very similar inverse function. And that's why it's nice to pair them together. So the inverse cosine function is labeled with this little negative 1 up top. It is not equal to 1 over the cosine, which would be secant. Instead, it is equal to arc cosine. this is important to remember. Now, we can't use the same interval that sine used. And let's think about why we can't use that. So here's our circle, as good as it's going to get. Sine went from negative pi over 2 to pi over 2. But now let's take a look at cosine. So for cosine, we input a value, let's say a half, and we're supposed to output an angle. So the output again is an angle. Now we want the cosine, we want the angles whose cosine values are 1/2. So we want the angle whose cosine value is 1/2. Well, from negative pi over 2 to pi over 2, that happens twice. Look. Here and here, these guys both have a length right here of 1/2. So we can't use the same interval because the calculator, the computer, anything that's acting as a function can't output just one value because there will be two values out over this. You should really think about why that is. If that just confused you, you need to stop this, replay it again, and think about why there are two values there. So what we do is instead of going from negative pi over 2 to pi over 2, we have to switch this up, and we have to go from 0 to pi for our angles. So our angles are over here. Now if you ask for the cosine of 1/2, there's only one guy that has a cosine of 1/2, because if you try to reflect it over here, this guy is negative 1/2. Okay, so this answer right here is pi over 3. So the range of arc cosine is restricted between 0 and pi. These are the only possible outputs. And when we are up here and you start giving me angles for arc sine, the range is restricted to this interval. And these are the only possible outputs.